Simplifying radical expressions. First example, square root of 8m to the fourth. All right, so you've seen this in the quadratic formula where you're taking the square root of a number, and this time we're going to be throwing some variables in there. All right, the variables are actually easier than the numbers. It actually takes less work to find the square root of a variable. All right, so first off, we're going to break this up. We're going to prep all our square roots. So I'm not taking the square root of anything yet. All I'm going to do is just prep it. So if I have 8, the square root of 8, I can't take the square root of 8. But I want to break it up into two factors. All right, this is where you should start definitely memorizing all your perfect squares. 1 squared, 2 squared, 3 squared, 4 squared. At least I would know at least up to 20 and know them well. All right. So what two factors multiply to 8? One being a perfect square. Yeah. So this one's nice and easy. So I got 4 times 2. Now notice I didn't take the square root of anything yet. All I'm doing is prepping it. M to the fourth. If my variable has an even exponent, leave it alone. It's just the way I want it. I want it to be even. So now when I go back and say, okay, now what do I take the square root of? The square root of 4, I'm going to say is 2, and it goes outside the radical sign. The square root of 2 I can't take, so I'm just going to circle it because it's going to stay inside my radical. M to the fourth, nice and easy. Just take half of it. So this becomes m squared, and whatever is left, I keep in my radical. So my answer is 2m squared radical 2. M squared, so why is m to the fourth the square root of m to the fourth m squared? Because the product of m squared times m squared is m to the fourth. Just like the square root of 9, 3 times 3 is 9. All right, so you just take half of it, which makes the variables nice and easy. Next example. 32a to the first. A squared. So I want to break up 32. Factors of 32, again, what two numbers multiply to 32? Again, try to think of perfect squares. 8 and 4, but think bigger. 16 times 2, okay? 16 times 2. And on a squared, I'm going to leave it just the way it is. A squared, because it's even. Square root of 16 comes out as a 4. Square root of 2, can't do it. I'm going to leave it inside. Okay. A squared. I'm going to take half of this, and it comes out as a to the first power. What's left? Square root of 2. So here's where I have to be careful. Right now I'm taking the square root, so there's an imaginary 2 here. All right? So the square root is an even. This number is even. But when it comes outside of the radical, it comes out as an odd number. All right? So if I have a number, a squared, versus a to the first, if a hypothetically was negative 3, what would a squared be? Positive 9. If a is negative 3 here, what would a be here? Just negative 3. So when this happens, there's going to be a difference in signs. So when I put this, if I plug in here, my a will become positive 9. If I put in a here, it becomes negative 3. So it's going to change my sign of the problem. So I want to prevent this from happening. And there's a way to prevent this. How do I keep a number always positive? Yeah, I'm going to take the absolute value. So if you have an even exponent, if your exponent's even, and it comes out of the radical sign as an odd exponent, to protect its value or its sign, I'm going to put an absolute value here. So this becomes 4 times the absolute value of a radical 2. Let's try another one. We have 16b cubed. All right, so I'm going to prep this again. 16 is already a perfect square. I'm going to leave that alone. B cubed. Can I take half of 3 and get an integer? No, I can't take half of 3. So I want to break up and prep 3 for myself. So I'm going to break up 3 into b squared times b to the first. And I always just take one less because I want to get this exponent to be even. Any odd number becomes even if you take one less of it. So any odd number. B to the fifth, you want to prep this, so it will just become b to the fourth, b to the first. If you have b to the seventh, this will become b to the sixth, b to the first. Always going to be one less. All right, so if you do this, this would be square root of 16, which is 4. The square root of b squared, half of b is just b. And then the square root of b to the first just stays inside as b. Now, since this started as an odd, you don't have to worry about the signs or the absolute value. Okay? It has to start as initially it has to be an even number coming out as an odd, or an even exponent coming out as an odd. If it's odd, it's fine. Next one. 50x to the ninth. factors of 50. Thinking perfect squares.
25 and 2.
Perfect. 25 times 2, x to the 9th. Do I want to leave this alone or do I need to modify it? Yeah, let's do x to the 8th times x to the 1st. Okay, x to the 8th times x to the 1st is x to the 9th. I have my even exponent. Square root of 25, 5. Square root of 2. I'm going to circle it, stays inside. Square root of x to the 8th, x to the 4th. Square root of x to the 1st, stays inside. So I have 5x to the 4th, radical 2x. Now, I'm crossing out, putting circles around these things. You don't have to do that. It's just what helped me keep everything organized. Eventually, when you guys got these down packed, you could do away with it. But if this helps you in the beginning, I would definitely do it. Next one. 180, x to the 4th, y to the 5th. All right, so I want to break up factors of 180. What are factors of 180? So this one's a little harder to see. What are factors of 180? So I'm just going to do this one on the side here. What are factors of 180? Can anybody tell me what 2 factors of 180 are? If you can get a perfect square out of it, that would be great. But if you can't, what else can you do? What else can you do? 9 and 20. Okay, you can do 9 and 20. There's one perfect square. 9 is a perfect square. But 20, can I break up 20 still? Yeah, what can I break up 20 into? 9 times 4 times 5. So you can do this. You don't have to do it in one step. It can be in multiple steps here. So square root of 9, 3. Square root of 4, 2. But when you bring both these numbers on the outside, you have to multiply these two. So 3 times 2 is 6, and then you're left with radical 5. Okay, so if you don't see, so really what the perfect factors were of 180, you could, if you've seen it, it was 36 times 5. But again, if you don't see it right away, keep breaking it down. All right, x to the 4th stays as x to the 4th. Y to the 5th, do I need to break this up? Why? Because it's odd, so let's go y to the 4th, y to this 1st. And then pick it apart. Square root of 36, 6. Square root of 5, stays. Square root of x to the 4th, x squared. Square root of y to the 4th, y squared. Square root of y to the 1st, stays inside. So I got 6x squared, y squared, 5y. Okay, our next example. Square root of 75, a to the 10th, b to the 6th. 75 is not a perfect square. Perfect. 25 times 3. A to the 10th, it's even. I'm going to leave it alone. So I got a to the 10th. And b to the 6th, that's also even. I'm going to leave that one alone as well. Take the square root. Square root of 25 comes out as 5. Square root of 3 stays. Okay, so I should be on my toes here. I have this even power. A to the 10th. Square root of a to the 10th comes out as a to the 5th. So it was even, and now it comes out as an odd. What do I need? Absolute value. B to the 6th becomes b to the 3rd, or b cubed. It was even, came out as an odd. What do I need? Absolute value again. So then radical 3. So you have 5 times the absolute value of a to the 5th times the absolute value of b. All right, so here we have the square root of 63u v to the 4th. So I'm going to break this up. Factors of 63. 9 times 7, good. U to the 1st stays as u to the 1st. V to the 4th, it's already even. I'm going to leave it as v to the 4th. Simplify. Square root of 9, 3. Square root of 7 stays. Square root of u to the 1st stays. Square root of v to the 4th comes out as v squared. So 3v squared, radical 7u. Okay, next one. Difference here is I have a number outside the radical. So this just pretty much this just means 5 times the square root of all that. So I'm going to take that 5 and multiply by whatever comes out. So let's prep this. Square root of 72. What 2 factors of 72? 8 and 9, bigger. 36 times 2. M to the 4th, it's even. I'm going to leave it alone. P to the 4th, it's even. I'm going to leave it alone. And Q squared is also even. I'm going to leave that alone as well. Square root of 36, 6. Radical. Oops, sorry. 6. Can I take the square root of 2? stays. Square root of m to the fourth. It's even. It's coming out as a even. Do I need absolute value? No, no absolute value. P to the fourth, p squared, q squared. Q to the first, need absolute value because it came out as an odd exponent. I had a 5 here originally, so I have 5 times this. When I do 5 times this, we have a square root of 2 left over. Combine these two. What's 5 times 6? 30, so let's get rid of this and put a 30 there. So I have 30 m squared p squared times the absolute value of q times radical 2. So last example, -7 times the square root of 245x squared y to the fourth z squared. I'm going to prep this. -7 times what? What can I break 245 in? Yeah, excellent. So 49 times 5. I saw that 245 ended in 5, so the first thing I try to do is divide by 5. It worked out nicely. X squared is already even. Leave that alone. Y to the fourth is even. And z squared is already even. So I have -7 times square root of 49, 7. Radical 5 stays inside. X squared comes out as the absolute value of x. Y to the fourth comes out as y squared. Z squared comes out as absolute value of z. What's left? Radical 5. Combine like terms here. -7 times 7. -49. Absolute value of x. Y squared. Absolute value of z. Radical 5.